So now the real challenge. Sorry, I'm just messing up the screen. So we have to try to do this if this whole difference of squares complicated thing, if the factor is the second thing. So like in this first one, these all use difference of two squares. Sometimes I tell people that, like, if I try to factor square squared minus triangle squared, I get square minus triangle times square plus triangle, just to kind of help you sort it out what this factoring pattern is. We've been using this for a couple weeks now. So if we identify that this is a difference of squares, which it is, I'm going to set up something minus something and something plus something. And this first thing gives us a y and a y. And this second thing is x minus 6 squared and just gives us x minus 6 and x minus 6. Now, we are not quite done. Like before, I need to drop the parentheses. But if I drop them in this first one, the negative is going to distribute and give me an x minus x plus 6. And then I get y plus, that's just a plus 1, so there's no change in sign, x minus 6. And this is the final factored form. Each of those can't go any further. In the second one, if I see that it's a difference of squares, I'm going to set up the same plus, well, let's just do the minus first. It really doesn't matter which one comes first. Minus and a plus. And I'm setting up big grouping symbols. And when you guys come in for help, I'm going to say, did we set up big things? Because we'll fix it later. This 1 becomes a 1 and a 1. And this becomes just a 5x plus y and a 5x plus y. And there's no escaping it. You absolutely have to put those in parentheses. And then as the next step, we're going to distribute the negative. So I get 1 minus 5x minus y. And here I'm just going to drop the parentheses, 1 plus 5x plus y. And now that's done. Next, if I go to the next two, I can see that this actually is more complicated. So I'm still going to have to do some pretty big parentheses and do a minus and a plus. And for this first set, this just becomes an m minus 6, and then an m minus 6. And this second set, this becomes an x plus 2 and an x plus 2. And you absolutely must put the parentheses. We're going to drop them in the next step. So in the next step, I'm going to look at this whole thing. I'm going to decide that this m minus 6 can drop because there's just a 1 in front of it. That's like a positive 1. And this x minus 2, that has to change sign because it's like a negative 1 in front of it. So I get that, minus x minus 2. Here, the m minus 6 parentheses drop and it just stays the same, and plus x plus 2, those drop. So I've dropped those parentheses that were inside. And lastly, we're just going to add like terms. M minus x, and then negative 6 and negative 2 would be negative 8. And then m plus x, and negative 6 plus 2 is negative 4. And that's my final. Number 4, also a difference of squares, also going to go with a minus and a plus. And so if I look at what's splitting up here, it's just going to be a and a. If I look at what's splitting up here, it's just going to be the entire b squared plus c squared. And this is going to be b squared plus c squared. Then if I distribute the negative, I get a minus b squared and minus c squared. And if I distribute nothing, because there's just a plus 1 to distribute, it's just a plus b squared plus c squared. And that's done. I know it looks like that can factor more, but it really can't. Now, we're going to do some more greatest common factor factoring, and these are a little bit more complicated. Looking at this one, I have 3 terms, and they all have a z or an x minus 17 in common. So that's going to come out in parentheses as one group, and then what's left behind is just 6 plus y minus z. That's pretty easy. In this one, I'm going to bring out a y squared minus 25 from the 2 sets, and I'm leaving behind a 3 plus a. But this can go further, and that can become y minus 5 and y plus 5. And 3 plus a is just going to stay 3 plus a, or you can put a plus 3. Doesn't matter. Next, I see that these are almost in common, but they're not quite. We need to make them be in common. So what I can do to make them be in common is I can pull a negative out of one of them. So if I pull a negative out of one of them, and it doesn't matter which, I'm just going to do the second one. So I have 6z minus y, and then instead of a plus, I'm going to put a minus, and that minus is going to change the order of these two. It's going to make the negative 6z become a positive 6z, and it's going to make the positive y become a negative y. And if I write it that order, now I have the two of them matching. So I'm going to pull out the 6z minus y, and that's going to leave behind a 5x minus 1. Don't forget the minus 1. It doesn't just disappear. There's still a 1 there. So that is the correct final form. In this one, I see that x minus 5 and 5 minus x are almost the same thing, but not quite. So what I want to do is let's change the second one again. Instead of a minus y, we're going to make it a plus y. And by pulling a negative out, this becomes x minus 5. And then I'm going to pull out the x minus 5, and I get 3x plus y. The last one here looks easy, but there's a lot of tricks to it. This is one of my favorites. Let's look at this, this, and this, and if I pull out the x to the fourth minus x squared, I'm going to leave behind x squared plus 8x plus 7. Looks like we'd be done, and this is correct so far, but this can go further because it can have a greatest common factor. I can pull out an x squared, and then I get x squared minus 1. And x squared plus 8x plus 7. But this can go further, and that can give me an x minus 1 and an x plus 1. And actually, this can go further. That can split up into two binomials, x and x, 7 and 1, and plus and plus. And then finally, I see that these two are in common, so I should really write this as x squared, x plus 1 squared, then x minus 1, and x plus 7. So that is a fully factored form of this, and there's a problem like that hidden away in your homework. Good luck, and I'll see you when I get back.